Hello everyone, and welcome to another episode of Rory Explained. This time we're going to be talking about pressure. Water pressure, air pressure, stuff. Let's go! Here's an example of a mass resting on a table. Because the mass is in contact with the table over an area rather than just at a point, the force applied by the table to the mass is in the form of a pressure. In situations like this, calculating the pressure is very easy, because the pressure is just the force divided by the contact area. This works out to be 1,000 newtons per square metre. Now let's consider the example of a glass of water. You might think that the pressure at the bottom of the glass depends on its shape and its area and its depth. But that's not the case. The only thing that matters when you're calculating water pressure is the depth of the point whose pressure you're trying to calculate. This is true because water is a fluid, meaning its shape has to be maintained by pressure applied from the container it's in. In this next example, a piston has been fitted to the water container. Despite the fact that it's not directly under the water's surface, a force still has to be applied to the piston to prevent the water pressure from driving it out of the container. That force is equal to the average pressure on the piston face, multiplied by its area. We can use water pressure as a means to store and generate electricity. Pressure at the water's surface here and here is the same, but the pressure at the bottom of this pipe is very high due to its depth beneath the surface of the upper reservoir. This means that the water can be released through a turbine, which converts the pressure difference into energy. A more complex example of fluid pressure is the atmosphere. Due to the changes in air density at different altitudes in the atmosphere, the equation that represents air pressure is more complicated. At ground level, the atmospheric pressure is approximately 100,000 newtons per square metre. That's the equivalent of the force due to 2 elephants standing on 1 square metre of ground. If you go up 5 kilometres, the pressure halves. Above 13 kilometres, the pressure is only an eighth of what it is on the ground, the equivalent of the weight of a small car for every square metre. At an altitude of 33 kilometres, the atmospheric pressure is equivalent to 1 person's weight per every square metre. And above 50 kilometres, the atmosphere is so thin that it barely exists at all. Thanks for watching this episode of Rory Explain. If you have any questions, or any topics you'd particularly like me to tackle, put them in the comments below.